Hello. This is a short segment on simplifying expressions involving compositions of trigonometric and inverse trigonometric functions by Silvana Bester. Now, what I do when I'm working these kind of problems, I have a procedure that I use. These are the main steps. I use a substitution for the inverse trig function, and to do that I let an angle equal the inverse trig function. So I write down let theta equal whatever the inverse trig function is that I see. Then I write down what I need to evaluate so I don't forget, and then I box it in. Step 3, I undo the inverse trig function. Step 4, create a reference triangle using the relationship that I found in step 3. And then, using the reference triangle from step 4, evaluate what I wrote down in step 2. So let's go through a few examples. Example 1. Suppose we're given cosine sine inverse of a fourth. Now, in step 1, I would write down let theta equal the inverse sine of a fourth. So, in step 2, what I'm really trying to evaluate is the cosine of theta. If I let all of this be theta, then I'm going to evaluate the cosine of theta once I make my substitution. So that's what I'm trying to find. In step 3, I'm going to undo the inverse trig function. So if I have theta equal to inverse sine of 1/4, to undo things I'm going to take the sine of both sides. So I'll have sine of theta equal to, these cancel out, 1/4. Now, this is what I'm going to use to build my reference triangle. The sine of theta equal to 1/4. So in step 4 then, working with this, sine of theta equals 1/4, and using your knowledge of relationships, this is going to be y over r. Now, since the inverse sine is valid in the restricted domain of the original sine function is from negative pi over 2 to pi over 2, and this is positive, then my reference triangle technically is in quadrant 1. Okay. So here's theta, and y would be 1, r is going to be 4, and now I can use the Pythagorean theorem to find x. Since I know that x squared plus y squared equals r squared, I can say that x squared plus 1 squared equals 4 squared. So x squared plus 1 equals 16, and x squared equals 15. Take the square root of both sides. Technically, its absolute value of x is square root of 15, and so x is plus or minus square root of 15. But here we're in quadrant 1, so we know we take the positive. So here we have x equals square root of 15. Okay. Now we go back to step 2, where we had written that we were going to evaluate the cosine of theta. And now I have a way of doing that because here's theta. Since the cosine of theta is going to be x over r, now I just look at my triangle, my reference triangle, and I see x is square root of 15, r is 4. And that is my final answer. Let's take a look at another example. Suppose we have cosecant of inverse tangent of -7/2. Now, again, first step is I go ahead and do a substitution. Let theta be the inverse tangent of -7/2. Okay. Now, what I want to evaluate is the cosecant of all of this, but I've just let all of that be theta, so I'm going to evaluate the cosecant of theta. And that's eventually what I want to find. Now, In step 3, I want to undo the inverse trig function, since I have written down that it's tan inverse of negative 7 halves. I'm going to take the tangent of both sides. And so essentially I have that tangent of theta is negative 7 halves. And this is what I'm going to use to create my reference triangle. So, step 4, creating my reference triangle. Given that tangent of theta is negative 7 halves, and I know that tangent is defined as y over x, and also don't forget that the tangent, the restricted domain, is from negative pi over 2 to pi over 2. So just kind of quickly on the unit circle, that's going to look like this. That means I could have my reference triangle anywhere in here. Since this is negative, I'm going to have to be here in quadrant 4. So in quadrant 4, I draw myself a reference triangle. Here's theta. And I know that y would have to be the negative in quadrant 4. So it could be x or y, but in this case we're in quadrant 4. X is positive, y is negative. Here x is positive 2. And again, to find r, we know that r squared equals x squared plus y squared. So r squared equals 2 squared plus negative 7 squared. So r squared equals 4 plus 49. And so essentially we have r squared equals 53. And then taking the square root, we have r is equal to plus or minus square root of 53. But again, we know that the hypotenuse has to be positive, so r is square root of 53. Now, that allows us to go back. Now that we've got a reference triangle, we can finally evaluate what we wrote in step 2. We were looking for the cosecant of theta, but cosecant is defined as r over y. So looking back at our triangle, we have r and y. So square root of 53 divided by negative 7. That's our answer. Okay. And now let's do a third example that's a bit more abstract. So example 3. Suppose we have secant of cotangent inverse of a over b, and we're given, for example, that a over b is positive. Okay, so again, following the same procedures, it doesn't matter that it's abstract, that I don't know what a and b are. I can still work this problem. So I still say let theta be cotangent inverse of a over b. Then what it is I want to evaluate is the secant of theta. Okay, and so then as I go and undo the inverse trig function, I'm going to have, starting out, I'm going to take the cotangent of both sides. And so essentially I just have cotangent of theta equal to a over b. And that's what I'm going to use to build my reference triangle. So, in step 4 then, I start to build my reference triangle, and I have cotangent of some angle, theta, is a over b. But remember, we were told a over b is positive. And so when thinking back, the restricted domain of cotangent was from 0 to pi, which visually looks like this. So I could have my angle being anywhere in quadrants 1 or 2. Since I know this is positive, I have to be in quadrant 1, because here x would be negative, y would be positive. I'd have a negative ratio. Since I have a positive ratio, I must be in quadrant 1. So let's go ahead and make our reference triangle. And we have that cotangent of theta equals a over b, which cotangent is x over y. So essentially I have x equals a, y equals b, and I have to find r. So r squared equals a squared plus b squared. And r is going to be the square root of a squared plus b squared. Again, r has to be positive, although technically it'd be plus or minus. We know it has to be positive. There's my reference triangle. So now I go back and remember what it is I was looking to evaluate, and that was the secant of theta. Okay, and since secant is r over x, I look over here, r over x, I'd have the square root of a squared plus b squared over a. That is my answer. So, those were the examples we worked out. So I've got one for you to do as practice. And try cotangent of secant inverse of 3/2. And when you're done, you should get 2 over the square root of 5. Good luck, and thank you for listening.